Hello viewers, in today's session we are going to discuss another important problem from domain of functions, and here we have to find out the domain of this function f of x, that is square root of sine inverse, and here we have in the square brackets 2 times the natural log of x minus 1 over e, where e is the exponential number. So in order to find out the domain of this function, will make use of the concept of principal value branch or the range of sine inverse function. So we know that sine inverse theta, the range of sine inverse theta belongs to the interval minus pi by 2 to pi by 2, where theta belongs to minus 1 to 1. So here we have minus pi by 2, and here we have pi by 2, and here we have 0, right? So this concept will be used to find out the domain of the function f of x. So here the first condition is that this entire term which is under the square root sign, it has to be greater than 0. So sine inverse, that is 2 times of natural log of x minus 1 over e, it has to be greater than 0, or this entire term should be positive, because we cannot have a negative expression inside the square root sign, because in that case the number becomes a complex number. But here we are dealing with only the real numbers, right? So this term, that is sine inverse 2 times natural log of x minus 1 over e, this entire term has to be greater than or equal to 0. So now let us take this term as theta. So if we assume theta is equal to 2 times natural log of x minus 1 over e, then this inequality now becomes sine inverse theta greater than 0, right? And from this range of sine inverse theta, we have sine inverse theta lying between minus pi by 2 and pi by 2, that is sine inverse theta should be greater than or equal to minus pi by 2, but less than or equal to pi by 2. But here we have sine inverse theta greater than or equal to 0. So it implies that sine inverse theta must be greater than or equal to 0, but less than this number, that is pi by 2. So here sine inverse theta cannot go beyond minus pi by 2, that is towards the left of minus pi by 2, and sine inverse theta cannot go beyond pi by 2, that is towards the right of pi by 2. So sine inverse theta cannot exceed this number, that is pi by 2, or sine inverse theta is equal to pi by 2, right? So sine inverse theta must be greater than or equal to 0, but less than or equal to pi by 2. So now we have to modify this inequality, that is sine inverse theta has to be greater than or equal to 0, but less than or equal to pi by 2, because sine inverse theta has to be a positive, right? So we have to discard this interval, that is from minus pi by 2 to 0. So we cannot take the values of sine inverse theta which lies in this interval, and we have to accept only this interval, that is from 0 to pi by 2. So this is 0 and this is pi by 2, right? So now we have to solve this inequality. So let us take the sine of all these three terms. So we have sine of 0, and then we have sine of sine inverse theta, and here we have sine pi by 2. Now the value of sine 0 is 0, and sine pi by 2 is equal to 1. So here we have 0, and here we have simply theta, because we know that sine of sine inverse theta is equal to theta when theta belongs to this interval minus 1 to 1. So here we have simply theta, and sine pi by 2 is 1. So now we have this inequality. So let us substitute the value of theta over here. So we have 0, and then 2 times natural log of x minus 1 over e, and here we have 1, right? Now let us divide throughout by this number 2. So we have here a 0 over 2, that is simply 0. Here we have natural log of x minus 1 over e, and here we have half. So now to solve this inequality, we have to make use of an important concept, right? Now see this function, that is y is equal to log of x to the base a, where a is greater than 1. So if a is greater than 1, then this function is an increasing function, right? So here we have this inequality, that is log of say x to the base a is greater than or equal to c but less than or equal to b, then the solution of this inequality can be written as a raised to c less than or equal to x, and here we have a raised to b. So here a natural log of x can also be written as log of x minus 1 over e to the base e, right? And obviously e is greater than 1. So if we compare this inequality with this one, then the value of c is 0, and the value of b is half, and for a we have e, right? And for x we have x minus 1 over e. So now using this inequality, the solution of this inequality can be written as a raised to c. So we have e raised to 0, and then we have simply here x minus 1 over e, and here we have e raised to half. So now here we have e raised to 0 is 1, then we have x minus 1 over e, and here we have e raised to half, that is square root of e. So now adding 1 over e throughout, so we have 1 plus 1 over e, and here 1 over e get cancelled when we add 1 over e throughout. So here we have x, and here we have 1 over e plus square root of e. So the domain of this function f of x is now given by this interval that is closed from both the ends. So we have 1 plus 1 over e to 1 over e plus square root of e. So this is the required domain of this function f of x. So here it is important to note that while solving this inequality, we have used this concept, right? And here we have said that y is equal to log of x to the base a when a is greater than 1 and x is obviously greater than 0, because the domain of this function should be x greater than 0. So this function is an increasing function, and when we have c less than or equal to log of x to the base a and less than or equal to b, then the solution of this inequality is given by this one. So x greater than or equal to a raised to c less than or equal to a raised to b, right? But here we can directly solve this inequality by raising all the three numbers here to the power of e. So we can also write it like this: e raised to 0, then we have e raised to log of e, and here we have x minus 1 over e, and here we have e raised to half, and using this result e raised to log of e, and here we have p is equal to p. For p we have x minus 1 over e. So we can now write here e raised to 0 is 1, and then we have e raised to log of x minus 1 over e as e to the base e. So using this expression we have simply x minus 1 over e, and here we have e raised to half, that is e raised to 1 over 2. So this inequality is same as this one.